Why should we study numbers, a counting tool for the primitive people? Primitive people usually obtained their food by hunting and gathering. They did not feel the need to count because what mattered most to them was finding something to eat, not finding out how much they had. However, the problem of distribution arose as they started living in groups and it became necessary to share food. This led to the development of the concept of numbers. Of course, it was not like today, when we precisely how many of something there is. Their counting ability remained at the very basic level that allowed to recognize whether the amount of leftover food had increased or decreased. According to researchers, animals are capable of telling whether there is roughly a lot or little of something. As primitive societies had gradually developed into tribal societies, people needed numbers. Each tribe that lived in the unit of families required knowledge about the number of its members, livestock, and enemies. The concept of numbers was critical for their survival. Today, we use Arabic numerals to record and count. Then, why do we have to study the concept of numbers and counting methods used in old times? Numbers did not just appear out of nowhere. They have become what they look like today through a long history of formation and modifications. Solving problems by using equations is not all there is to mathematics. We have to know how mathematical concepts were created and how they are utilized today. Numbers were the first outcome humans obtained from observing nature that they completely depended on for survival. If we understand how numbers were developed, we can figure out the secrets in nature to some extent. This is why we are studying this mathematical topic. As people gave up hunting and gathering and began to form tribes, they started to raise livestock and farm crops. The idea of ownership sprung up from the extra produce. Humans began to exchange extra produce with one another, which led to a natural creation of the concept of numbers. However, every tribe used different methods to count. Some tribes counted up to 2 and thought anything more than that was just many. In contrast, other tribes engraved markings on branches and compared them with the number of sheep to count their livestock. This is an example of the previously mentioned one-to-one correspondence. As mentioned, counting methods were different for different tribes. Thus, it was highly inconvenient to compare or calculate the number of livestock that was counted differently for each tribe. This inconvenience brought about the development of numbers. Most people think that numbers and numerals are the same. Technically speaking, however, they are different. Numbers are used for counting objects or represent quantity, size, or order of subjects to count. Simply put, numerals symbolize numbers. For example, numerals are the symbols representing numbers, such as 0, 1, 2, to 9. Numbers include numerals to show magnitude, quantity, order, and more. When we say 3 flowers or 3 oranges, these 3s are numerals. The number 3 is how the numeral of 3 is represented in the Hindu Arabic numerals. Number 80 is a 2-digit number, numeral 8 is placed at 10's place and numeral 0 is at 1's place. Digit 8 and 0 are symbols that make up the number 80. However, even the same number can have different meanings. Take the example of 7, which may have the following 3 meanings. First, it can be cardinal numbers that count sets or measure quantity. Second, it can serve as ordinal numbers that show an order to mark things like first, second, third, to seventh floor. Third, it can act as nominal numbers, playing the role as symbols like social security numbers of phone numbers. As such, May 7th look the same wherever it is used, but what it represents could be completely different. The meaning of 3 on its own in 3 people differs from one another. When units are used with numbers, the meaning of the numbers become clearer. When it simply says 3, we would just relate it to a concept of quantity. However, when numbers are paired with units, such as 3 animals, 3 atoms, 3 hours, 3 meters, and 3 pounds, we can know precisely what the 3 refers to. Even without digits, primitive people could associate their body parts like fingers with numbers to count objects or record in the form of memory in their heads. Besides, they were able to count from 1 to 22 by going around the upper body starting from the little finger on the right hand. However, when they needed to count more than 22 or count animals, they sometimes made mistakes in the process. This is why they developed one-to-one correspondence between an animal and a small pebble to make sure they were counting correctly. Let us look at an example. Suppose that an old lady who did not know the concept of numbers and never learned to count owned many animals. The livestock left the pen to graze grass in the morning and returned in the evening. The old lady knew precisely if all the livestock that had left the pen in the morning had come back. How could she solve this problem when she did not have a tool for counting numbers at all? She used a method known as one-to-one correspondence. Every morning, she put 2 large baskets at the entrance of the pen and only one of them was full of pebbles. She picked up and moved pebbles one by one to the empty basket every time an animal left the pen. In other words, she put pebbles and animals in one-to-one correspondence, 1 pebble for each animal. Therefore, when all the animals left the pen, the same number of pebbles had been moved to the empty basket. In the evening, this time, she moved 1 pebble to the opposite basket in correspondence to each animal that returned. The old lady would have immediately realized if some animals had not returned should there be even a single pebble left in the basket. Just like this old lady, primitive people had methods for counting although they did not have numbers as a tool. In order to keep records, the Incan Empire in South America used quipu, a thick string made of easily accessible wool or cotton, and attached multiple pendant strings to it. Each pendant string had additional strings attached to it, and the size and position of the knots represented numbers. In addition, they used different colored strings. Gold, white, and green colors symbolize gold, silver, and grains, respectively. Quipu made it possible for Inca people to count objects and do calculations that were slightly more complex. The wisdom of the Inca people amazes us even today, as they tied knots on strings to represent numbers at a time when there were no letters or numbers. Even before people had a system for recording their lives and passing them on to others, they had the concept of numbers. How did ancient people understand numbers? How did they count? It is difficult to know for certain, but we can easily guess how they understood numbers by looking into their lives. The study of mathematics first began from observing and understanding nature. As mathematics was introduced to ancient Greece from ancient Egypt, it became logical and human-centered. Although mathematics taught in ancient Greece did not overlook the importance of nature, its excessive focus on humans and societies could have led to a period of stagnation of mathematics. Mathematics is a study of discovering the secrets of nature. Today, mathematicians are turning their attention back to the mathematics advocated by the natural philosophers in ancient Greece. Still, we can broaden our understanding of mathematics if we learn how people in the past came up with the concept of numbers, how they developed the method of counting, and the expression of numbers in the numerical systems between numbers. What is the logical evidence for saying that numbers are the basis of everything? The concept of numbers developed as people began to own and store objects. In primitive societies, people could not count as accurately as we do today. After counting one or two, they would have quickly thought that there were just too many. They would have counted using tools in nature when there were no convenient numbers we have today. Primitive people associated fingers or body parts with numbers to count the number of objects and remember it. They could count up to 10 by associating each finger with an object. However, this was inconvenient when counting more than 10. For that reason, they began to use natural tools in place of their fingers. For example, they made a mark on a tree or a bone each time an animal passed by, which allowed them to know how many animals were living in a mountain. In some movies, a prisoner would draw lines on the wall to figure out the number of days spent on the prison. The number of lines allows him to record and keep track of the days since when he was imprisoned. Numbers are not used only to count objects. The concept of numbers was also needed to exchange goods with other tribes. For instance, let us think about an exchange between fish with coconuts. There would be nothing difficult about exchanging a fish with a coconut. However, what should we do if we wanted to exchange a large number of objects at once? To begin with, we could draw markings to show the number of fish and pair it with each coconut as we move them. Once there are no more markings left to match, we would stop moving the coconut. If there were no more coconuts even though the markings remain, we could take out the fish from the pile by pairing it with the remaining markings. Although primitive could not know the exact number of objects, they could exchange goods accurately with each other through this method. As mentioned before, the Incan people used the knot known as quipu that enabled them to count numbers. They hung additional strings to the long and thick main rope. The knots on each string represented numbers. In addition, they could count and record the number of various objects by using different colors of strings for each category of objects. As such, the primitive people were able to count and represent numbers with materials found in nature. They utilized nature as the best tool for mathematics. In that respect, we could say that the primitive people were the best mathematicians. There are many intriguing meanings in numbers. The number 1 is the start of all numbers and represents the person who is in the highest position among all. Moreover, sometimes it is called the number of blessings as it means the beginning. The number 2 describes the harmony and balance among phenomena or objects in all the universe including the earth. It also represents the yin and yang, the sun and the moon, sky and ground, man and woman, father and mother, good and evil, and black and white. The number 3 stands for comfort and synthesis, and it is the favorite number of Asians, especially Koreans. When we distinguish time, we speak of 3 categories: past, present, and future. The sky, land, and humans may also be embodied in the number 3. The number 4 means an accomplishment. In Asian countries, 4 is associated with death, but it means a complete number and sometimes is the number of patience in Western countries. There are 4 seasons: spring, summer, autumn, and winter. Besides, 4 means perfection, referring to the 4 seasons of spring, summer, autumn, and winter, to the directions of east, west, south, north, and in-body types of Chinese medicine. The number 5 is the same the number of fingers on a hand. It also means everything we have. Simply put, 5 represents the whole. In Asia, 5 was related to Wuzing, the 5 elements in the ancient Chinese theory explaining most worldly phenomena, and Wulun, the 5 Confucian relationships. The representative Western examples of 5 include the 5 rings in the Olympics and 5-star generals. The number 6 appears in hexagonal pavilions, hexagonal prisms, and hexagonal water that symbolize the harmony and balance in nature. It serves as an index of human culture. The lucky number 7 represents loyalty, honor, victory, and realization of hope. Its typical examples are 7 days of the week, 77 years of age, an important point in life in Asia, July 7th in the lunar calendar, 7 stars in the constellation Big Dipper, and the 7 colors in the rainbow. The number 8 means misfortune because it symbolizes war and destruction in the West. In contrast, Asian countries use it to refer to someone with the optimal body proportions or someone talented in every field. Especially in China, people regard it as the luckiest number because they believe 8 brings wealth and prosperity. The number 9 contains both joy and misfortune at the same time. In Asian countries like Korea, the age that includes the number 9, such as 29, 39, 49, and 59 are disliked because it is thought to represent the demise of the youth and old age. The number 10 is the basis of all arithmetic. Decimal numbers are one example. 10 is accepted as a number that represents law, order, and power, while also being an illustration of the vast universe. What did people in the past think was the essence of everything? How was soil, stones, plants, animals, air, and other materials made? Sugar water can be split up into sugar and water. But what are sugar and water composed of? No matter how closely we look, the components that make up the different matter do not reveal themselves to our bare eyes. Natural philosophers of ancient Greece were also curious about what the objects around them were composed of. Thales, the father of Western philosophy and a natural philosopher, observed the process of plants budding, growing, and blooming when all he did was water them and concluded that water was the origin of all things. On the other hand, Empedocles saw earth, air, water, fire, as the 4 basic elements of all things. These basic elements are not created, destroyed, or changed. He believed all things were created as a result of the combination and separation of these elements through the forces of love and hate. Aristotle accepted Empedocles' interpretation and believed that objects were formed and changed through to the combination of not only earth, air, water, and fire, but also qualities of hot, cold, dry, and wet. Greek philosopher Leucippus stated that the essence of all things was an indivisible particle that was in motion in space. Leucippus' theory was passed down to his pupil, Democritus, and it was Democritus who named this indivisible particle an atom. An atom was considered to be so strong that it was indestructible. Democritus stated that atoms of various shapes and sizes gathered and scattered, creating various matter in nature and changes in it. Democritus went further and even attributed living organisms, the senses, and thoughts to atoms in motion. We can see that there are two positions in explaining objects, one that explains through elements such as earth, air, water, and fire, and one that explains through atoms. Every person has intellectual curiosity. According to Plato and Aristotle, humans pursue philosophy because humans are capable of being marveled. People take up philosophical reasoning because they feel marveled at something, which calls upon intellectual desires, leading to philosophical thought. What most people marvel about is the specific truth they experience. For example, ancient people who had no knowledge about celestial movements would have been surprised by the solar eclipse, where the sun suddenly darkened, and would have wanted to know the reason for the phenomena. The eclipse would have been an object of amazement in itself. However, Thales marveled about things on a completely different level from average people. He came to a somewhat strange question at the time of what is the origin of all things. He asked himself this question and tried endlessly to find an answer. Thales was not just curious about specific and empirical truths but had an intellectual curiosity for a more fundamental issue. Of course, the answer to these questions does not make our lives more comfortable or help us have an abundance of goods. Thales' goal with these questions was not comfort or abundance but knowledge itself. Thales is called the father of philosophy because he was the first person in human history to start studying the fundamental issues that pursued knowledge in itself. Further, he did not rely on supernatural forces for these answers and instead sought rational explanations to such questions. Mathematics, the subject we are dealing with in this book, is about numbers. Pythagoras once said, "All is number," meaning that number is the essence of all things. Then what did other philosophers believe to be the origin of all things? Only by understanding this question can we understand the essence of numbers Pythagoras is talking about. Why did Thales, a natural philosopher, believe water was the origin of all things? Thales left few records that we can access today. It is said that Thales was intrigued by astronomy and wrote a study on the winter and summer solstices and spring and fall equinoxes, but none of these remain to this day. This means that we can learn about Thales indirectly through the records of other philosophers that watched him. According to the records of the likes of Plato and Aristotle who wrote of Thales, he claimed the origin of all things was water. It is recorded that other philosophers also agreed with the argument of Thales that water was the origin of all things because they could observe the need for moisture for the change of air, clay, and earth to be possible. Still, it is difficult to imagine that they really observed the process of water becoming clay or earth. Plato specified that water has to condense to become stone and earth, while it has to melt or disperse to become vapor or air. It is said that Thales claimed that the earth was floating on water and that the earth was created from this very water. Thales is a Greek natural philosopher from 7th century BCE. It may seem inappropriate to interpret and evaluate Thales' statement from such a long time ago using today's standards. However, compared to the claims of other philosophers of his time, his thoughts were extremely reasonable. In Protagoras, Plato names Thales as the first in his list of the 7 sages of Greece. He said it was because Thales asked various questions of many different fields and answered them using logical explanations. Thales is also well known for predicting a solar eclipse. It is also said that he used his knowledge of ratio between similar triangles to measure the actual height of the pyramid using the length of shadows created by a stick and the pyramid while traveling in Egypt. There were as many philosophical theories as there were philosophers in ancient Greece. Among them, a theory more difficult to comprehend than the argument, "Water is the origin of all things," is one that says the origin of all things is numbers. This was an argument set forth by the Pythagorean school. If someone were to ask us to explain what number is, we may feel hesitant, but we all know what it is. Still, the statement that numbers make up the material world is puzzling. Are numbers tangible or are they intangible? There are many ways to distinguish between the two, but the first method that comes to mind is that we can see the tangible, but not the intangible. Have you ever seen numbers? If we were to see a number 1 on a TV screen, is that a number? We must first be able to differentiate between a number and numeral. What you would be seeing is a numeral, not a number. A numeral can be tangible. However, the number it represents is not tangible. This may be difficult to understand, but let us approach from a more fundamental standpoint. Let us see what Pythagoras meant by, "all things are number." The reason this is so hard to understand is that all things are tangible while numbers are intangible. Then how are we to understand this statement? It is said Pythagoras was born around 570 BCE and died around 490 BCE. It is also said that around 5th century BCE Pythagoras' pupils became an influential political force in southern Italy. It is more accurate to say that it was the claim of the members of the Pythagorean school, rather than Pythagoras himself, that all things are numbers. According to Aristotle's response to the statement, the Pythagorean school thought that numbers were hylomorphic. Hylomorphism looks at the matter that comes to existence as the essence's given form. It can also be understood as the acceptance of various forms in the process through which matter is created and transformed. To the Pythagorean school, numbers were tangible rather than intangible. To them, numbers were of material nature like air and water. This was why they thought that numbers could be components that made up the material world. Why did they think this way? The answer lies in geometry, which studies figures. The Pythagorean school thought that the material world was made up of points, lines, planes, and dimensions. They corresponded each with 1, 2, 3, and 4 respectively. It was this mindset that led to their argument everything in the material world to be made up of numbers. Of course, if you go deeper into this statement, we quickly find that it is not very convincing. Are the geometric objects, such as points, lines, planes, and dimensions, that make up the material world really tangible? Have you ever seen a point? Could we call a dot a point? Some scholars say that such extreme thinking does not represent the Pythagorean school. This is because the mathematicians that led the Pythagorean school after Pythagoras' death had a different argument about the principle of things. Then, how should we accept the Pythagorean school's claim that numbers are the origins of all things? To understand this argument, we must find a clue in harmony. Music, which is both harmonious and beautiful, can be expressed as numbers. It is said that Pythagoras was passing by a forge one day and discovered 3 harmonious notes from the sound of a hammer hitting an. He thought that such harmony could be discovered not only in music but also in the universe. Therefore, the harmonious universe could also be expressed as a number. The harmonious traits of the universe that could be expressed in numbers was called the tetrarchies, the harmony in which the sirens sing. This was the core of the Pythagorean school's cosmology and the driving force behind the development of modern science. Why was the abacus made and how was it used? The abacus is one of the oldest inventions of mankind. The abacus was first made around 3000 BCE in Mesopotamia and is still used today. It was first used by thinly spreading sand on a flat board and using a finger or a stick to make markings. The biggest advantage of an abacus is that it can be applied to any system of numbers and can accurately record and calculate very big numbers. The abacus was used in ancient Egypt and Greece, and it was even taught in Roman schools. Roman accountants use an abacus, a portable calculator. Also known as a Roman abacus, an abacus was a calculating tool made by creating grooves on a board and putting beads on them to move up and down the grooves. Each bead on the upper grooves represented the number 5, while the 4 beads on the lower grooves each represented 1. The abacus could express up to number 9,999,999. Although the modern abacus come in different shapes and form depending on the region, the basic principle has never changed. The form of the abacus that is the easiest to understand is one with 10 beads in a row. Each row represents a different place value. That is, the beads on the different rows each represent 1, 10, 100, or 1000. For example, to show the number 4732, 4, 7, 3, and 2 beads on each of the rows beginning with the uppermost one would be shifted to the other end. Using this principle, it is also very easy to add or subtract. An abacus has the advantage that it is convenient to use to display and calculate numbers. However, it also has a few disadvantages. For example, it takes much practice to get used to using an abacus, and if we were to make a mistake in the process, we have to start from the beginning. Still, the abacus has been used for a long time because it has more advantages than disadvantages. People always seek convenience. In Europe, a mechanical calculator started to be developed in the 17th century. The mechanical calculator allowed us to easily calculate numbers without having to move each bead as in the case of abacus. All we had to know was what each button on the calculator represented. People today usually think of computers as machines that process data using electronic circuits. However, a computer used to refer to a calculator. This can also be seen from the fact that the word computer comes from compute, which means to calculate. The computer is the result of an endless effort to make calculations easy, and it has now become an integral part of everyday life. Math and science are so closely related that they are inseparable. Many scientific theories were formulated through mathematics, and various mathematical theories were needed to express various scientific truths. Why is there such a close relationship between math and science? This is probably because the world we live in is surrounded by numbers and calculations and composed of expressions and systems of numbers. All things consist of mathematical order and harmony. Only by agreeing to such thought can we even dare to start expressing the world we live in mathematically. The Pythagorean school, that said, all are numbers, were the first to recognize this. As this truth became accepted as a great achievement, the Pythagorean school came to have an indispensable intellectual status in human history.